Our story takes place in the emptiness of the cosmos, 13.8 billion years ago, when there were no stars, no planets, no life. Only energy compressed into an infinitely dense point. Then, in a moment beyond imagination, that point exploded, the Big Bang. From absolute darkness came light, matter, and time. Galaxies began to form. Stars were born and died in immense explosions, scattering the elements that would one day create worlds like ours. Among those countless stars, in a spiral arm of the Milky Way, a small solar system took shape. At its center, a young sun blazed with intensity. Orbiting it, fragments of rock and dust came together until they created a special planet, Earth. At first, it was a fiery inferno of collisions and chaos. But slowly, oceans appeared, the crust solidified, and the impossible began to happen. Life emerged. This is the story of everything we know, from the birth of the universe to the modern world we live in today. An epic journey of 13.8 billion years, filled with catastrophes, discoveries, and silent miracles. From the Big Bang to globalization, from cosmic silence to the noise of our cities. Join us as we unfold the complete history of Earth. I'm Oliver, and this is BioExplainer. If you enjoy history that is clear, exciting, and without unnecessary fluff, subscribe and turn on the notification bell. Leave your like right now, because at the end, you might forget. Let's begin. What if Earth had never formed? Where would humanity exist today?
The Great Explosion, the Big Bang and the birth of the universe. 13.8 billion years ago, everything we know, every star, every planet, every living being, traced back to a single moment, the Big Bang. It was not a bang like dynamite or a firecracker, but the sudden expansion of space itself. Imagine all the energy and matter of the universe packed into a space smaller than the head of a pin, then stretching outward in an instant. Time itself began in that moment. Before the Big Bang, there was no before. In the first fractions of a second, the universe was a searing ocean of energy. Temperatures soared into the trillions of degrees, hotter than the core of any modern star. Subatomic particles, quarks, electrons, neutrinos, flashed into existence, collided, and annihilated each other. Out of this chaos, the first simple atoms appeared, hydrogen and helium. They would later fuel the first stars and create the elements that make up our bodies. 380,000 years later, the universe cooled enough for electrons to combine with protons, forming the first stable atoms. For the first time, light traveled freely through space. Today, astronomers can still detect that ancient light as the cosmic microwave background, captured by satellites and radio telescopes. In observatories across the United States, from the deserts of Arizona to the peaks of Hawaii, scientists map this faint glow, reading it like a baby picture of the universe. Galaxies began to take shape. Gravity pulled hydrogen and helium into enormous clouds. As these clouds collapsed, their centers ignited, giving birth to stars. The first stars were titans, hundreds of times larger than our sun. They burned furiously and died young, exploding as supernovas that scattered heavier elements, carbon, oxygen, iron, into space. Every atom of iron in your blood, every atom of oxygen you breathe, was forged in one of these stellar furnaces. We are not just on the Earth. We are of the universe. Billions of years passed, galaxies clustered together. The Milky Way, our home galaxy, spiraled into being about 13 billion years ago. Within one of its arms, clouds of dust and gas swirled into a solar system. Around 4.6 billion years ago, our sun ignited, and from the leftover debris, planets formed. One of them, small and rocky, would become the stage for oceans, forests, cities, and humanity itself. It is humbling to remember that the universe is still expanding today. Galaxies race away from each other, carried on the stretching fabric of space. Astronomers using the Hubble Space Telescope discovered that not only is the universe expanding, it is doing so faster and faster. driven by a mysterious force called dark energy. Even now, billions of years later, the echoes of the Big Bang continue to shape our destiny. In places like New York's Hayden Planetarium, visitors stand beneath a vast dome and watch the birth of the universe unfold in breathtaking simulations. Children gaze upward, wondering how something so immense began from something so small. Questions remain unanswered. What triggered the Big Bang? Why does the universe exist at all? Will it expand forever or collapse back into itself? NTHE Big Bang was more than a beginning. It was an opening act. Space, time, matter, and energy emerged in one cosmic moment. The stars lit up, galaxies spun, and the chemistry of life was scattered like seeds across the cosmos. The Earth had not yet formed, but its ingredients were already drifting in interstellar clouds. And in that silence of space, the universe was waiting. Waiting for planets, for oceans, for creatures, and for us to wonder about it all. The birth of Earth, 4.5 billion years ago, in the swirling cradle of our solar system, dust and rock collided in endless violence. The sun had just ignited, and around it circled a disk of debris, remnants of gas and particles left over from its birth. Gravity, relentless and patient, drew these fragments together. Some shattered on impact, while others fused into growing bodies. Over millions of years, these collisions sculpted planets. One of them, forged in fire, would become Earth. In its infancy, Earth was unrecognizable. Instead of oceans and blue skies, it was a molten inferno. Meteors bombarded its surface daily, some larger than mountains. Each impact melted rock, reshaping the planet again and again. Volcanoes erupted continuously, releasing gases into the air. The young atmosphere was toxic, a suffocating brew of carbon dioxide, methane, and ammonia. If you could stand there, though no human could survive, you would see rivers of lava glowing beneath blackened skies, lightning flashing through volcanic ash. One of the most dramatic events in Earth's history came with a collision so powerful it redefined the planet forever. A Mars-sized object, known as Theia, slammed into Earth. The impact was catastrophic. Vast amounts of Earth's mantle were hurled into orbit, glowing with heat. Over time, this debris coalesced into a companion, the Moon. At first, it orbited much closer, appearing enormous in the sky, pulling the oceans into towering tides. The Moon stabilized Earth's tilt, preventing wild shifts in climate. Without it, seasons might have swung chaotically, and life might never have flourished. As the planet cooled, a solid crust formed over the molten interior. Rain began to fall, perhaps for the first time, as steam condensed from the skies. Water collected in low basins, creating the first oceans. Scientists believe comets and icy asteroids added to this water, delivering frozen cargo during violent impacts. Imagine the Earth's surface transforming lava plains, giving way to shallow seas, steam rising from the waves beneath a dim, young sun, yet Earth's atmosphere was far from inviting. Oxygen, essential for us today, was absent. Instead, greenhouse gases trapped heat, keeping the young planet warm enough for liquid water, despite the sun shining 30% dimmer than it does now. This delicate balance, sometimes called the faint young sun paradox, was critical. Without it, the oceans might have frozen solid, halting the possibility of life. Meanwhile, Earth's surface shifted and cracked. Early forms of plate tectonics may already have begun. Giant slabs of crust floated on molten rock, colliding and tearing apart. These movements built primitive land masses that would one day drift into the continents we know: North America, Africa, Asia. The land was barren, covered with black rock and dust, but it was a beginning. NTO picture early Earth is to see a planet both hostile and full of promise. The sky glowed red with volcanic gases. Asteroids still rained from the heavens, yet oceans stretched across the surface, shimmering under a faint sun. Deep within those waters, chemistry was preparing the first steps toward biology. And even today, Scientists in the United States study Earth's origins by examining meteorites that fall in places like Arizona's deserts or Antarctica's ice sheets. These space rocks preserve traces of the early solar system, offering clues about the raw materials that built our world. At NASA's Johnson Space Center in Houston, researchers handle tiny fragments of asteroids collected by spacecraft, searching for answers to how Earth gained its oceans and atmosphere. Young Earth was far from peaceful. But it had all the ingredients: liquid water, stable climate, protective moon, and dynamic crust that made it unique. From chaos emerged stability. From fire emerged the possibility of life. And soon, in the dark waters of those first oceans, chemistry itself would awaken into something more. What came next would change everything. The origin of life. 3.5 billion years ago, Earth had already transformed from a fiery ball into a world with oceans, clouds, and rain. The stage was set for something extraordinary. Somewhere in those ancient waters, lifeless chemistry crossed an invisible threshold and became biology. From simple molecules, life emerged, a transformation so improbable that even today scientists debate how it happened. One leading theory imagines the early oceans as a vast, primordial soup. In this mix, gases like methane and ammonia mingled with water vapor. Lightning storms flashed overhead, and ultraviolet rays from the young sun bombarded the seas. Energy drove chemical reactions, building increasingly complex molecules. In 1953, American scientists Stanley Miller and Harold Urey tried to recreate this process in a lab at the University of Chicago. By sparking electricity through a mixture of gases and water, they produced amino acids, the building blocks of proteins. Their experiment showed that the raw materials for life could form under conditions similar to those of early Earth. Another theory points to hydrothermal vents deep in the ocean. Even today, these vents, located in places like the Pacific Ocean near the Galapagos Rift, release superheated water rich in minerals. Around these vents, strange ecosystems thrive without sunlight, relying on chemical energy. Some scientists propose that life's first cells may have originated in such environments, protected from the harsh conditions on the surface. NHOWEVER, it began. The first life was microbial. These organisms were simple, single-celled, and invisible to the naked eye. They did not breathe oxygen, because oxygen did not yet exist in the atmosphere. Instead, they drew energy from chemicals around them. For billions of years, these microbes ruled Earth, adapting to boiling waters, freezing surfaces, and acidic lakes. A monumental breakthrough occurred when some of these microbes discovered photosynthesis. By using sunlight to convert carbon dioxide and water into energy, they produced oxygen as a byproduct. At first, oxygen was a poison, killing many organisms that could not tolerate it. But over time, Earth's atmosphere transformed. Oceans absorbed oxygen until they overflowed, staining ancient rocks with rust. Then, oxygen filled the skies, paving the way for complex life. This event, called the Great Oxidation, was one of the most important turning points in Earth's history. And fossils from 3.5 billion years ago give us glimpses of these pioneers. In places like Western Australia, scientists have discovered stromatolites, layered rock structures built by colonies of microbes. Even today, living stromatolites grow in Shark Bay, Australia, forming dome-like structures that look much like their ancient ancestors. These fossils are silent witnesses, reminding us that life began humbly, with organisms smaller than grains of sand. The origin of life also raises profound questions that echo in classrooms and museums across the United States. At New York's American Museum of Natural History, visitors gaze at exhibits showing the earliest fossils and models of primitive microbes. At NASA's Astrobiology Institute, scientists study Mars and Jupiter's moon Europa, asking, if life could start here under such fragile conditions, could it also arise elsewhere in the universe? Is Earth unique or just one example of a cosmic pattern? What is certain is that once life began, it proved astonishingly resilient. Through asteroid impacts, volcanic winters, and shifting continents, microbes endured. They were small, but their influence was immense. By producing oxygen, they reshaped the atmosphere, set the stage for more complex cells, and forever altered Earth's chemistry. When we look at life today, towering redwoods in California, whales off the coast of Alaska, or humans walking through Times Square, it is humbling to know that it all began with fragile microbes drifting in ancient seas. NTHE's story of life was no longer about chemistry alone. Evolution had entered the stage. Variation, competition, and survival would guide life's path from single cells to multicellular complexity. And the rise of complex organisms. NFOR. Nearly 2 billion years, Earth was a planet of microbes. Oceans swarmed with bacteria and archaea, but the land was silent and barren. Life existed, but it was simple. Cells without nuclei, surviving in isolation. Then, something remarkable happened. Cells began to cooperate. This cooperation would become the foundation for all plants, animals, and eventually humans. Around 2 billion years ago, a dramatic evolutionary leap occurred. The origin of eukaryotic cells. Scientists believe this happened when one primitive cell engulfed another. Instead of digesting it, the smaller cell lived inside the larger one, creating a symbiotic relationship. That smaller partner eventually became the mitochondrion, the powerhouse of the cell. This merger allowed cells to produce energy more efficiently, fueling greater complexity. In plants, a similar event created chloroplasts, which capture sunlight and convert it into food. These symbiotic unions were quiet revolutions, reshaping the trajectory of life. Eukaryotic cells were larger, stronger, and more adaptable than their simpler ancestors. They contained internal compartments, organelles, that specialized in different tasks, like information storage, protein production, or energy conversion. With this innovation, life could grow more diverse. For the first time, cells had the capacity to form communities. NTHE's next leap was multicellularity. Instead of living alone, cells began to stick together. At first, they formed simple colonies, where each cell performed the same function. But over time, cells began to specialize. Some focused on movement, others on sensing the environment, still others on reproduction. This division of labor gave rise to more complex organisms. The logic is simple. Many parts working together can achieve far more than one alone. Then came the Cambrian explosion, one of the most astonishing bursts of diversity in Earth's history. Around 541 million years ago, life evolved at a pace never seen before. Within a geological blink, less than 50 million years, nearly every major body plan of animals appeared. Trilobites scuttled across the ocean floor, worms burrowed into sediment, sponges filtered water, and early arthropods experimented with shells and armor. NP-redation also emerged in force. For the first time, animals hunted each other actively, creating an evolutionary arms race. Some developed speed or camouflage, while others evolved armor or claws. One of the most fearsome predators of this era was Anomalocaris, a meter-long arthropod with grasping limbs and a mouth lined with teeth. To smaller creatures, it must have seemed unstoppable. NTHE Cambrian seas were alien compared to our modern oceans. Imagine swimming in shallow waters along the coast of what is now North America, where strange, segmented creatures crawled along the seabed. Some had spines, others had shells, while others pulsed through the water with fin-like appendages. None of these animals would look familiar to us, yet they were the prototypes of the diversity we see today. And fossils from sites like the Burgess Shale in Canada provide a window into this lost world. Preserved in extraordinary detail, they reveal creatures unlike anything alive today, some with stalked eyes, some with fan-like appendages, some so bizarre that paleontologists struggled for decades to classify them. Visitors to the Smithsonian National Museum of Natural History in Washington, D.C. can see reconstructions of these Cambrian creatures, a reminder that life's creativity is boundless. NWHY. Did the Cambrian explosion happen? Scientists debate the causes. One factor was oxygen. By this time, photosynthetic microbes had filled the oceans and atmosphere with enough oxygen to support larger and more active animals. Another factor may have been genetics. The evolution of Hox genes, which control body structure, allowed for more flexible designs. Ecology also played a role. Once predators emerged, prey species evolved new defenses, accelerating diversification. NTHE Cambrian marked the beginning of ecosystems as we know them, complex webs of producers, consumers, and decomposers. Algae captured sunlight, herbivores grazed, predators hunted, and scavengers cleaned up what remained. The rules of survival, competition, cooperation, adaptation were established, and this was the dawn of complex life. From microbes in the shadows of deep oceans, Earth had blossomed into a planet of animals. The blueprint of vertebrates, insects, and mollusks was already written in these early forms. Without this burst of innovation, there would be no fish, no birds, no mammals, and no humans. And yet, the story was only beginning. These creatures swam in seas, but they had not yet conquered the land. The first forests, the first insects, the first steps onto shore were still to come. The age of sea monsters and first vertebrates. And after the Cambrian explosion, Earth's oceans became battlefields of survival. For millions of years, invertebrates dominated, creatures like trilobites, mollusks, and arthropods. But a new blueprint was emerging, one that would define the future of life: the vertebrate. With a backbone and an internal skeleton, these animals could grow larger, swim faster, and protect their organs with bone. The rise of vertebrates was a turning point in evolution. NTHE first vertebrates appeared more than 500 million years ago. They were primitive fish, lacking jaws, with simple mouths and armor-like plates covering their bodies. Though small, they represented a revolution. A backbone meant strength, flexibility, and structure. This design would eventually give rise to sharks, reptiles, birds, and mammals, including us. NBY, the Devonian period. Around 419 to 359 million years ago, fish had diversified into astonishing forms. This era is often called the Age of Fishes. Some developed jaws, allowing them to bite, chew, and hunt more effectively. Sharks appeared, sleek and agile predators with cartilage skeletons instead of bone. Their design was so successful that sharks still thrive in oceans today, relatively unchanged after hundreds of millions of years. And among the most terrifying sea monsters of the Devonian was Dunkleosteus. This armored fish could grow over 6 meters, 20 feet long. Its skull was encased in massive bony plates, and its jaws snapped shut with crushing force, slicing prey in half. In an ocean filled with trilobites, smaller fish, and cephalopods, Dunkleosteus was the apex predator, a giant among giants. While predators roamed the seas, plants made a daring move onto land. Around 470 million years ago, the first moss-like plants spread across damp shorelines. Over time, they developed vascular tissues, enabling them to transport water and grow taller. By 400 million years ago, primitive forests covered parts of Earth, changing the atmosphere by releasing more oxygen. With plants came new habitats, and soon animals followed. Insects and arachnids were among the first land dwellers. Wingless, crawling forms scuttled across forest floors, feeding on plants and decaying matter. But the most dramatic pioneers were lobe-finned fish like Tiktaalik, discovered in Arctic Canada in 2004. Tiktaalik had both gills and primitive lungs, along with sturdy fins capable of pushing its body across shallow waters. It was part fish, part amphibian, the bridge between ocean and land. From creatures like this came the first true amphibians, able to breathe air and walk on solid ground. NTHE Devonian world was not stable. Continents drifted, colliding into larger land masses, while volcanoes and shifting seas altered ecosystems. About 375 million years ago, Earth experienced a mass extinction that struck marine life particularly hard. Coral reefs collapsed and many fish species disappeared. The causes remain debated. Volcanic eruptions, falling oxygen levels, or even asteroid impacts may have played a role. Yet extinction cleared the way for survivors to thrive. Amphibians diversified, plants expanded inland, and insects grew in size under oxygen-rich skies. The Carboniferous period that followed saw forests spread across swamps, laying down vast deposits of plant matter that would one day become coal, the very fuel that powered the Industrial Revolution in the United States millions of years later. Towering trees, some over 30 meters, 100 feet tall, created dense canopies. Giant dragonflies with wingspans the size of hawks patrolled the skies, while amphibians grew to monstrous sizes in wetlands. Vertebrates. This was an age of experimentation. Some remained tied to water, while others adapted further to life on land. The blueprint of tetrapods, four-limbed vertebrates, was now established. This design would evolve into reptiles, dinosaurs, birds, and mammals. The journey from fish to land dweller was one of the greatest transitions in natural history. And fossil evidence of this era is displayed in museums across the world, including the American Museum of Natural History in New York. Skeletons of ancient fishes and amphibians remind us of the struggle and creativity of evolution. Visitors look at the bones of Tiktaalik and imagine that first moment when a fish pulled itself onto a muddy shore, taking tentative breaths of open air. Oceans remained home to giants, but land was no longer empty. Life was expanding, diversifying, and adapting. The stage was set for new dominions: forests, deserts, rivers, and mountains, where future species would rise. The story of life was far from calm. Extinctions would strike again, reshaping ecosystems and testing survival. Out of these challenges, one group of reptiles would soon rise to dominate Earth on a scale unmatched in history. Dinosaurs, giants of the Earth. 150 million years ago, the Earth was nearly silent. The Permian extinction, the deadliest event in our planet's history, had wiped out almost 90% of all species. Oceans were empty of their former giants, forests were barren, and ecosystems struggled to recover. Yet from this devastation came opportunity. Among the survivors were reptiles, and from them a new lineage would rise. These creatures would evolve into the most iconic rulers Earth has ever known: the dinosaurs. At first, dinosaurs were modest in size. About 230 million years ago, during the Triassic period, they appeared as small, swift reptiles, no larger than a dog. But their design was revolutionary. Unlike other reptiles, their legs were positioned directly under their bodies, allowing them to move efficiently and support greater weight. They spread quickly across Pangaea, the single supercontinent that covered Earth at the time. As the Jurassic period began, dinosaurs expanded into astonishing forms. Sauropods, colossal long-necked herbivores like Brachiosaurus and Diplodocus, towered over landscapes, grazing on treetops beyond the reach of any other animal. Some weighed as much as 70 tons, heavier than 10 school buses. Their sheer size was a defense against predators, but it also reshaped ecosystems. Forests evolved under their browsing, and entire habitats revolved around their presence. Predators grew just as formidable. Allosaurus, one of the dominant carnivores of the Jurassic, hunted in packs, using sharp teeth and claws to bring down prey. Later, in the Cretaceous, Tyrannosaurus rex would become the king of predators. Standing over 12 meters, 40 feet long, with a skull nearly as tall as a man, T-Rex had one of the most powerful bites in history, crushing bone with every snap of its jaws. All dinosaurs were giants. Many were small, agile, and surprisingly bird-like. Fossils reveal that feathers were widespread among theropods, the group of dinosaurs that includes T-Rex and Velociraptor. Initially, feathers may have served for insulation or display, but over time they evolved for flight. This means that every sparrow in Central Park and every eagle soaring above the Rocky Mountains is a living dinosaur, carrying the legacy of its ancient ancestors. During this age, Earth itself was transforming. Pangaea broke apart into smaller continents, shaping the geography we recognize today. This separation isolated dinosaur populations, allowing new species to evolve. Some thrived in lush tropical forests, others in windswept deserts, and even in polar regions where months of darkness tested survival. The diversity was immense. Over 700 species of dinosaurs have been identified, with new discoveries each year, many displayed in museums like the American Museum of Natural History in New York, NA. Alongside dinosaurs, other creatures flourished. Flying reptiles called pterosaurs filled the skies, some with wingspans as wide as a small airplane. Marine reptiles like ichthyosaurs swam through oceans, streamlined like dolphins but armed with sharp teeth. Plesiosaurs glided through waters with long necks and paddle-like limbs. Crocodiles, turtles, and lizards also emerged, many in forms familiar to us today. Mammals too had appeared, though they remained small, nocturnal, and overshadowed by their towering reptilian neighbors. NFOR, over 160 million years, dinosaurs ruled Earth. Their reign lasted far longer than humans have existed. They adapted to shifting climates, volcanic eruptions, and continental drift. They grew into giants, flew through the skies, and grazed in herds across plains. For all that time, they seemed unstoppable. Then came disaster. About 66 million years ago, an asteroid nearly 10 kilometers, 6 miles wide, slammed into what is now the Yucatan Peninsula in Mexico. The impact released energy billions of times greater than the most powerful nuclear bombs. Shockwaves rippled across continents. Forests ignited in global wildfires. Tsunamis taller than skyscrapers swept across coastlines. Dust and ash filled the atmosphere, blocking sunlight for months. Plants withered, food chains collapsed, and 3/4 of all species, including most dinosaurs, perished. Yet not all was lost. A small group of feathered dinosaurs survived, evolving into modern birds. Tiny mammals, once hiding in burrows, now had room to flourish. From this destruction, a new chapter in Earth's history began, the Age of Mammals. Dinosaurs left behind bones buried in stone, later uncovered by humans. Today, children in New York, Denver, and Los Angeles press their faces to glass cases in museums, staring up at towering skeletons of Tyrannosaurus rex or Triceratops. For them, dinosaurs are both monsters of the past and reminders that Earth has always been a place of change, destruction, and renewal. The fall of the dinosaurs was sudden, shocking, and final. For millions of years they had dominated the Earth, yet in a geological heartbeat, they were gone. The Age of Mammals and Human Evolution. When the asteroid ended the reign of the dinosaurs, Earth was plunged into chaos. Fires swept across continents, skies turned dark, and ecosystems collapsed. For a time, the planet seemed nearly lifeless. But small creatures endured. Among them were mammals, once overshadowed by giants, now poised to take center stage. In the aftermath, mammals seized the opportunities left behind. Freed from the dominance of dinosaurs, they diversified into countless forms. Some grew to enormous sizes, like the massive Indricotherium, a rhinoceros relative that towered as tall as a 2-story house. Others specialized as swift hunters, like saber-toothed cats with dagger-like teeth. Whales, whose ancestors once walked on land, returned to the oceans, becoming the largest animals ever to live. Bats mastered the night skies, navigating with echolocation. From forests to plains, from deserts to icy tundra, mammals conquered every habitat. Paleogene and Neogene periods, spanning from 66 million to 2.5 million years ago, were ages of experimentation. Continents shifted toward their modern positions, climates cooled, and grasslands spread. Herds of grazing animals thundered across vast plains, chased by predators in scenes that resemble today's African savannas. In North America, ancient bison, camels, and horses roamed freely. Fossil beds in Nebraska, South Dakota, and California reveal this vanished world, preserved in stone for modern scientists and museum visitors. Amid this diversity, one group of mammals stood apart: the primates. Living in tropical forests, primates developed grasping hands, forward-facing eyes, and larger brains. These traits gave them an advantage in climbing, seeing depth, and solving problems. From these early primates came apes, and from apes came the first hominins, the ancestors of humans. And around 7 million years ago in Africa, some apes began walking upright. This small adjustment, bipedalism, was revolutionary. Freed from knuckle walking, these hominins used their hands to carry food, craft tools, and protect themselves. Fossil footprints preserved in volcanic ash, such as those at Laetoli in Tanzania, show families walking side by side, a quiet moment echoing through millions of years. The genus Homo appeared about 2.5 million years ago. Homo habilis, known as handyman, crafted stone tools by striking rocks together, creating sharp edges for cutting meat and plants. Fire soon followed. With flames, humans gained warmth in cold nights, light in darkness, protection from predators, and the ability to cook food. Cooking unlocked more nutrients, fueling the growth of larger brains. Homo erectus spread far beyond Africa, reaching Asia and Europe. They hunted, cooperated, and adapted to diverse climates. Evidence suggests they built shelters and may have communicated with primitive language. For nearly 2 million years, Homo erectus endured, longer than our own species has existed so far. Then, about 300,000 years ago, our species appeared, Homo sapiens. With advanced language and symbolic thought, humans painted caves in France, carved figurines in Germany, and buried their dead with rituals. They built boats to cross seas, reaching Australia and beyond. While Neanderthals thrived in Europe and Denisovans in Asia, Homo sapiens outlasted them, though traces of these cousins remain in our DNA. Ice Ages tested survival. Vast glaciers spread across North America, Europe, and Asia. Mammoths and mastodons roamed frozen plains, hunted by humans armed with spears and cooperation. Across a land bridge called Beringia, people crossed from Siberia into Alaska, spreading through the Americas. Archaeological sites in New Mexico and beyond reveal evidence of these early Americans, who adapted to deserts, forests, and coasts, creating cultures as diverse as the landscapes they inhabited. 10,000 years ago, as the last ice age ended, humans had spread across the globe. They gathered in villages, farmed crops, and domesticated animals. Hunters and gatherers became builders of towns. This transition would spark civilization itself. The Age of Mammals was more than just the story of survival after dinosaurs. It was a saga of growth, innovation, and adaptation. From small nocturnal creatures hiding in shadows, mammals became rulers of Earth. And among them, one species rose with unmatched creativity and ambition. From walking upright on African plains to standing in Times Square beneath glowing screens, humans represent a journey billions of years in the making. And yet, the challenges of survival and adaptation remain the same. The next chapter would not only reshape humanity, it would reshape the planet. What came next would change everything. The birth of civilization. About 10,000 years ago, as the last ice age retreated, Earth entered a new chapter. Vast glaciers melted, rivers swelled, and fertile valleys emerged across the continents. Humanity, once nomadic and dependent on hunting and gathering, began to settle. People planted crops, domesticated animals, and built permanent homes. This shift, known as the Agricultural Revolution, was the spark that ignited civilization. In the Fertile Crescent, stretching from the Mediterranean to the Persian Gulf, people learned to cultivate wheat and barley. Domesticated sheep, goats, and cattle provided meat, milk, and wool. For the first time, humans controlled their food supply rather than chasing it. Surpluses allowed communities to grow larger. Villages became towns, and towns became cities. With stability came innovation. Mesopotamia, the land between rivers, gave birth to the first urban centers around 5,000 years ago. Cities like Ur and Babylon thrived with temples, palaces, and bustling marketplaces. Writing appeared, cuneiform etched into clay tablets, to record trade, laws, and myths. Mathematics and astronomy advanced as priests tracked stars to predict floods and seasons. The Epic of Gilgamesh, one of the world's first great works of literature, echoed across generations. Along the Nile River, Egypt flourished. The annual floods enriched the soil, sustaining vast populations. Pharaohs ruled as god-kings, commissioning pyramids and temples that still inspire awe. Advances in medicine, architecture, and engineering pushed the limits of human achievement. Even today, the Lincoln Memorial in Washington, D.C., with its columns and symmetry, reflects Egyptian and Greco-Roman inspirations, proof that ancient civilizations continue to shape American culture. Farther east, the Indus Valley Civilization built carefully planned cities like Mohenjo-Daro and Harappa, with streets laid out in grids and advanced drainage systems. In China, dynasties rose along the Yellow River, cultivating rice, crafting bronze, and developing philosophies that would influence the world. In the Americas, early cultures grew maize, built ceremonial centers, and created calendars that reflected deep astronomical knowledge. Civilization also brought religion and law. People looked to the heavens for meaning, worshiping gods of sun, sky, and harvest. Temples rose as centers of faith, while rulers claimed divine authority. Law codes, like that of Hammurabi in Mesopotamia, set rules for justice and order, carving humanity's first steps into governance and society. Trade flourished, connecting distant lands. Caravans crossed deserts with spices, metals, and textiles, while ships navigated rivers and seas. Goods carried ideas, writing, mathematics, and artistic styles. These early networks laid the foundations of globalization long before airplanes or the internet. NBUT civilization came with challenges. Hierarchies emerged, dividing kings, priests, and warriors from farmers and slaves. Wars broke out over fertile land and resources. Disease spread through crowded cities. Inequality became woven into human history. Yet, alongside struggle came progress. People built monuments, advanced science, and imagined futures beyond survival. NBY, the time empires rose, Greece, Rome, Persia, and beyond. Humanity had mastered architecture, governance, and philosophy. In Athens, democracy was born. In Rome, engineers built aqueducts and roads that stretched for thousands of miles. These legacies endure in the modern world. American democracy, for instance, draws inspiration from Athenian ideals, while the layout of Washington, D.C., with its Capitol dome and marble columns, echoes Roman grandeur. NTHE, birth of civilization, turned scattered human tribes into builders of culture, science, and power. Seeds planted in ancient soil grew into traditions that still shape us today. From clay tablets to skyscrapers, from pyramids to the internet, the arc of history began with the first farmers who chose to settle. Humanity had entered history, writing its story not only on stone and papyrus, but also in the landscapes of cities that still endure. Yet the march of progress was not finished. Revolutions of thought, discovery, and technology would soon carry humanity into an age of even greater transformation, the age of discoveries and revolutions. As civilizations matured, humanity's hunger for expansion, wealth, and knowledge grew stronger. The Middle Ages in Europe, often remembered for knights, castles, and cathedrals, were also marked by limitations. Most people lived and died within the same small villages. Travel was dangerous, and horizons seemed narrow. Yet by the late Middle Ages, curiosity was stirring again. The Renaissance, rebirth, ignited in Italy and spread across Europe, blending art, science, and rediscovered classical wisdom. In Florence, Michelangelo sculpted David out of marble, while Leonardo da Vinci sketched flying machines centuries before airplanes existed. Across Europe, the printing press, Invented by Johannes Gutenberg around 1440, revolutionized communication. Books that once took months to copy by hand could now be printed in days. Knowledge spread like wildfire. In time, ideas that began in Renaissance Europe reached across the Atlantic, influencing the birth of the United States centuries later. NBUT, the Renaissance, was only the beginning. The 15th and 16th centuries ushered in the Age of Discovery. Ships set sail into uncharted waters, driven by ambition, trade, and sometimes desperation. Christopher Columbus crossed the Atlantic in 1492, linking Europe to the Americas. Vasco da Gama rounded Africa to reach India, while Ferdinand Magellan's expedition circumnavigated the globe. These voyages connected continents in ways never before imagined. Goods, ideas, and diseases traveled with them. Potatoes and tomatoes reached Europe. Horses and wheat arrived in the Americas, and diseases devastated indigenous populations. Scientific revolution soon followed, shattering centuries of belief. Nicholas Copernicus placed the sun, not Earth, at the center of the universe. Galileo Galilei peered through a telescope and saw moons orbiting Jupiter, proof that not everything revolved around us. Isaac Newton, in the 17th century, formulated the laws of motion and gravity, describing how apples fall to the ground and planets move in the heavens. Science shifted from speculation to observation, from faith alone to evidence. And then came the Enlightenment, a revolution of ideas. Philosophers like John Locke, Voltaire, and Montesquieu questioned kings, empires, and rigid hierarchies. They argued for liberty, equality, and democracy. Across the Atlantic, their words found fertile ground. In 1776, the American colonies declared independence, inspired by Enlightenment ideals. The United States Constitution, drafted a decade later, became a model of representative government, balancing power and protecting rights. When Americans visit Independence Hall in Philadelphia today, they stand in the very room where Enlightenment principles became reality. Meanwhile, revolutions shook Europe and beyond. The French stormed the Bastille in 1789, toppling monarchy in the name of liberty and fraternity. Across Latin America, independence movements drew inspiration from both the American and French examples. Humanity was learning to imagine new political orders, challenging traditions that had endured for centuries. In BUT, the revolutions were not only political. The Industrial Revolution transformed economies, societies, and landscapes. Starting in Britain in the late 18th century and spreading across Europe and America, it harnessed coal, iron, and steam. Factories rose in cities, replacing handcraft with machines. Trains raced across landscapes, reducing journeys from weeks to days. Telegraph wires carried words instantly, shrinking the world further. In the United States, cities like New York, Boston, and Pittsburgh became industrial powerhouses. Immigrants from across the world poured into factories, chasing opportunity while facing harsh working conditions. Skyscrapers climbed into the sky, railroads stitched the continent together, and the Statue of Liberty welcomed newcomers to a land of promise and struggle. The Industrial Revolution fueled scientific advances. Charles Darwin published On the Origin of Species in 1859, introducing the theory of evolution by natural selection. His work connected humans to the same natural processes shaping every creature, a revelation that challenged both science and faith. In medicine, vaccines and antiseptics saved countless lives. In engineering, bridges, dams, and canals reshaped landscapes. Humanity was not only adapting to nature, it was mastering it. Yet progress came with costs. Factories belched smoke that darkened skies. Rivers filled with waste. Workers, including children, labored long hours in unsafe conditions. Cities grew crowded, and inequality sharpened. Social movements rose in response. Labor unions, abolitionists, suffragists. Their struggles planted seeds for rights and freedoms that Americans still fight to preserve today. By the end of the 19th century, the world had been remade. Oceans were crossed by steamships, landscapes carved by railroads, and skies spanned by telegraph lines. Empires stretched across continents, and industrial powers competed for dominance. Humanity had transformed its world faster than ever before. NTHE, Age of Discoveries and Revolutions, marked humanity's graduation from ancient tradition into modernity. The ideas of liberty, science, and industry converged, reshaping societies on a global scale. It was a time of brilliance and brutality, of progress and exploitation. And as the 20th century approached, the momentum of discovery and invention carried humanity toward new heights and new dangers. What came next would change everything. The contemporary era, the globalized world, NTHE 20th century, opened with optimism, but its first decades brought devastation on a scale the world had never seen. The First World War, sparked in 1914, drew in nations from Europe, Asia, and North America. Trenches stretched across fields, and new weapons, machine guns, tanks, chemical gas, killed millions. In the United States, young soldiers crossed the Atlantic, and when they returned, the world they had left behind had changed forever. The war ended in 1918, but its scars ran deep. Barely 2 decades later, the world was again at war. The Second World War engulfed continents from 1939 to 1945, leaving cities in ruins and tens of millions dead. The United States, after the attack on Pearl Harbor in 1941, mobilized its vast resources. American factories built planes and tanks, while soldiers stormed beaches in Normandy and fought in the Pacific. The war ended with a moment both triumphant and terrifying: the dropping of atomic bombs on Hiroshima and Nagasaki. With them, humanity entered the nuclear age. After 1945, the Cold War divided the globe into 2 camps, the capitalist United States and the communist Soviet Union. For decades, the world teetered on the brink of nuclear destruction. The Cuban Missile Crisis of 1962 brought humanity closer than ever to annihilation. Yet the Cold War was also an engine of progress. The space race put American astronauts on the moon in 1969, a moment of wonder broadcast live across living rooms from New York to Los Angeles. Neil Armstrong's words, "One small step for man, one giant leap for mankind," captured the imagination of a generation. NTHE's second half of the 20th century was a period of rapid transformation. Automobiles filled highways, airplanes shrank continents, and televisions brought global events into American homes. Computers, once massive machines housed in universities and military bases, shrank into personal devices, paving the way for the digital revolution. The Internet, born from military research, connected people in ways unthinkable just decades earlier. Social revolutions reshaped societies. In the United States, the civil rights movement, led by figures like Martin Luther King Jr., challenged segregation and demanded equality. Women fought for rights in workplaces, schools, and politics. Across the globe, colonies gained independence, reshaping the world map. The ideals of democracy and freedom spread, but so did conflicts, inequality, and new struggles. As the 21st century dawned, globalization reached unprecedented levels. Trade and finance linked nations together. Goods manufactured in Asia filled American stores, while Wall Street fluctuations sent ripples across the planet. Culture became global. Hollywood films, American hip-hop, Japanese anime, and Latin American music transcended borders. Airplanes made the planet smaller, while satellites circled overhead, guiding GPS devices and capturing weather patterns. Yet globalization came with challenges. Climate change emerged as the greatest environmental crisis in human history. Burning coal, oil, and gas filled the atmosphere with greenhouse gases, heating the planet. Glaciers melted, seas rose, and storms grew fiercer. In the United States, hurricanes battered the Gulf Coast. Wildfires swept through California, and drought strained the Midwest. Scientists warned that without action, future generations would inherit a dangerous planet. And conflicts also changed form. The September 11th attacks in 2001 shocked the United States. collapsing the Twin Towers in New York and reshaping global politics. Wars in Afghanistan and Iraq followed, as terrorism and extremism became defining concerns. Meanwhile, cyber attacks and information wars created invisible battlefields where nations and individuals fought not with tanks but with data. Despite turmoil, science advanced at breathtaking speed. The Human Genome Project mapped our DNA, unlocking secrets of biology. Advances in medicine extended lives, while artificial intelligence began transforming industries. Space exploration reached new frontiers. Rovers roamed Mars, telescopes captured images of distant galaxies, and private companies like SpaceX reimagined the future of space travel. Once again, Americans looked to the stars, dreaming of journeys beyond Earth. Then came a global test unlike any before, the COVID-19 pandemic. In 2020, a virus spread across the globe in weeks, shutting down cities, grounding planes, and halting economies. From New York to Los Angeles, streets emptied, hospitals overflowed, and millions lost their lives. The pandemic revealed both the fragility and resilience of humanity. Vaccines, developed in record time, became symbols of scientific triumph, showing how global cooperation could confront global threats. Today, Earth is more interconnected than ever. A protest in one city can spark movements worldwide. A financial crisis in one nation can ripple through global markets. Environmental disasters remind us that the planet's health is tied to human survival. Humanity has conquered so much, yet faces challenges that demand unity: climate change, inequality, disease, and the responsibility of wielding powerful technologies. From the Big Bang to the skyscrapers of New York, from trilobites crawling in Cambrian seas to astronauts orbiting Earth, the story of our planet has been one of constant transformation. The Earth has been shaped by cosmic chance, natural forces, and human imagination. Its history is fragile, immense, and unfinished. Then the most pressing question remains: what comes next? Humanity now holds the power to destroy or preserve, to explore or to retreat, to write the next chapter with wisdom or with folly. The story of Earth continues, and each of us is part of it. What if Earth had never formed? Where would humanity exist today? If you are not subscribed yet, don't forget to hit that button and join us for more incredible journeys through history. Thank you for watching. Earth's story is far from over. Which of these names would you like to see here next? Isaac Newton or Cleopatra? Tell us in the comments below.